let's take a look inside our ME333 lab kit box that hopefully everyone has by now. Pop it open. So the first thing you should find is your NU32 PIC32 breakout board. It's inside of a breadboard, and there's also a 16:2 LCD screen plugged in. And you should note that where the LCD is plugged in is kind of random. It can unplug, and you can plug it in somewhere else. We'll be playing with that very soon. Okay, we've got a little plastic mirror. I'll post another video of what we're going to do with this, but when you're building your circuit, it helps to sometimes be able to show someone by debugging, and you have to hold it up to your webcam. It gets a little hard to use 3 hands to have to hold that up. So this mirror can be used with this individual long purple wire in your kit to turn your the webcam of your laptop into a document camera. Okay, what's next? There's a second breadboard, and in this breadboard are 3 more printed circuit boards. You might have a green chip or 2 green chips instead of purple, but they're just different colors. They're the same chips as these. These are the chips we'll be using for our final project. You can also take these out. They're just randomly put in if you need more space on another breadboard. So this is your spare breadboard, and we're just putting these chips in here for storage for now. Okay, there is a mini USB cable. That's to get programming and debugging communication with the NU32. And there is a power brick. This is a 6-volt, 1-amp power supply for the NU32. There is a plastic baggie full of resistors and capacitors for building our circuits. There's a second plastic baggie with some LEDs, a push button, some comically large resistors. We'll need those in our projects. There is a black 4AA battery pack. This will power our motor when we start doing our motor project. There are 4 AA batteries to go into the battery pack. There are 2 alligator clips. Now if you look at the battery pack, it's got 2 bare stranded wires at the end. They don't plug into your breadboard very well. So when we finally need these in the motor project, we'll use the alligator clips to clip onto these loose battery wires, and then the other end of the alligator will get plugged into the breadboard to power the motor. Then there's the motor. This is a brushed DC motor. It has an encoder on the back. This plastic disc, if you look very closely, has lots of little lines on it. Don't do what I'm doing. Don't touch it, because that's the sensor, and we don't want to scratch it. There is a cable that comes out of that with 6 wires. That cable ends in a printed circuit board that brings the 2mm pitch of the cable into 0.1 inch to plug into the breadboard. The motor also has a black angle bracket so that you can attach it to your table, and there's a press fit gear on the end. And to act as a load, something for us to spin, is this laser cut acrylic bar. The non-papered side could get pushed onto this gear on the end. You don't have to do that yet. We'll use this in a few weeks. But that will act as the thing that we try to spin. That motor can spin 4,000 RPM, so it might get a little fast. This is a clamp for you to try to figure out how to clamp your motor to your table so that the bar on the motor doesn't turn into a propeller and fly away. And then finally, there's a bundle of wire for all the circuits that you'll be building. What didn't come in the kit, because you might have this from previous kits, are a pair of wire strippers. This wire is 24-26 gauge, so we're looking for wire strippers that go from 20 to 30 gauge for removing the insulation. This pair, the cutter is down here, and there's pliers up here if you need them. And generally the 24-26 size hole is good for stripping this wire. And don't forget, there's usually a little thumb lock, so you give it a little squeeze, you undo the lock, they open up, and then you can do your cutting and stripping. Then you'll need some kind of multimeter at some point. This is a nice multimeter from Adafruit, but there's all kinds of multimeters. Really, all we will need is the ability to read volts and ohms. So actually, we might read some current too. So DC volts, DC current, and amperage are really all you need. This one does farads. I don't think that's really necessary. And finally, we need some kind of oscilloscope. So here is an end scope. This is an oscilloscope, a function generator, and a power supply. We use these in all kinds of classes for learning analog circuitry like diodes and op amps and transistors. So we'll use this in this class to help calibrate some of our circuits and see the voltages that our microcontroller sees as a debugging tool. So stick all of that back in your box. Try not to let that heavy clamp crush anything. Don't let your batteries short, so you don't have to put those in their case yet. Watch the video on how to assemble the little mirror. It might help with debugging later. And keep out your ME32 board, your power supply, and your USB cable. Plug those in to your computer and test your Makefile setup and your NU32 utility to try to put Simple Pick and Talking Pick on your NU32.